Thank you, Laura. And also, before I start, I would like to thank the Arabal Organizing Committee for giving us the opportunity to conduct this workshop. And I would like to thank all of you for attending. And hopefully we can make it more interactive at the end as we reach the question and answer session, because we also would like to hear what you have to say about what we're presenting here today. So again, thank you. What I'll go through is basically three main items. I'll first introduce Dubal, what's Dubal, and then what do we do in the technology development transfer, what technologies do we have, and what services we provide. And then what we are looking into the next 3 to 5 years in terms of development. And at the end, we can have hopefully an interactive question-answer session. So just to take you through this year expected to produce over 1,035,000 tons. And also the other main product we have is water. Originally, Dubal actually main product was water when Dubal was commissioned. We were supplying at one time 40% of the water requirement of Dubai. We have a 30 million gallon capacity per day. We also have our own captive power plant to support the smelter with a 2,350 megawatt generation capacity. And also we have a cast house of about 1.2 million ton capacity. We also actually detached from Dubal, outside Dubal in the Jebel Ali port, we have our own berth where we receive our major raw material of alumina, coke, and pitch. And one time, this berth supported both Dubal and Imal in terms of raw material. This just, as a beginning, is just the different technologies employed today at Dubal. Actually, we're using one technology. We added in the middle of 2012, a new technology, what we call a D18 Plus, which is an upgrade of the D18. We'll explain that later. So you can see we have a wide range of technologies today used at Dubal, rating from 200 kiloamp up to 450 kiloamp. And these technologies, two of them are actually fully 100% designed, developed in Dubal. The other three were either purchased or developed in cooperation with Comalco of Australia. We'll just go through a brief history of Dubal. The actual site construction started in 1977, and the first hot metal was produced in November 1979. We had 3 pot lines of what we call P69 Kaiser technology, designed to operate at 150 kiloamp. Today we are running it at around 203. Significant changes were done to the technology to allow it to operate at higher amperage and also become more efficient. We'll look into certain numbers as we progress. After that, once the Kaiser technology was established, and then a lot of modification done to able to operate at a higher amperage of beyond 175, a decision was made in Dubal late in the 1989 to expand the capacity further by building potline 4, what we call a deep project. And this project actually was our first implementation were actually managed by Dubal team. And also this provided an opportunity of actual testing of new technology. So this was our first exposure to developing technology. This pot line was comprising of 144 pots to operate at 175. Today it's at 203. But 144, 5 of these pots were special pots, which were designed in cooperation with Comalco of Australia at the time. And that's what we call CD200. And it was a new design to operate in a range of 190 to 200 kiloamp, utilizing the know-how between Dubal and Comalco. And this project went quite well, but we had to do 3 major modifications to the design to get it working well. And after that, it was decided to adopt this technology in the further expansions at Dubal. So in 1996, we commissioned what we call the Falcon project, was utilizing this technology. As I said, the original technology design was 190 to 200. We commissioned the spotline at 195. Today is operating at 250 kiloamp. This location also provided us with another special location where all the subsequent technologies of Dubal will be developed, what we call a Eagle section. It's a group of 5 pods separated from the lines, provided with boosters, where we do all our testing and development so far. And I think, as you will see in the subsequent pictures later on, we're running out of space in that building, so we have to move away from that now. So subsequently to the pot line 5, an automatic replica was done of pot line 5, what we call a Condor project, pot line 6. At that point, actually, we are looking into further expansion. We thought of doing marginal design improvement at this time to test our abilities, but also to see what can be done better. A small modification was done to this design, and we introduced what we call at the time a D20. And in the meantime, between these 2 stages, I talked about the 5 test group. At the time, with Comalco, we developed what we call the CD26. It was a pot designed to operate between 220 kiloamp to 260 kiloamp. And this pot, actually, we kept it running almost up to around 2003 or 4. Design was very successful, but at the time, it did not meet our requirement of competing in a global market of technology transfer. But the package is ready, and we have that design. So 2003, Castrel was built, and then subsequently the same design, D20, was used for pot line 7, 7B, and 9B. Pot line 9 originally was built as a temporary pot line, where we were having problems with the original pot line's rectifiers. So the idea was to build it, then shut down these pot lines, then cut across the lines and connect the lines. And because at the time we were told you cannot do a replacement of rectifier with the currents on. Subsequently, I think the team came up with a solution, and then this pot line stayed, and the old rectifiers were replaced. So we had more pots to operate at the time. So going to the Eagle, where we had established the CD26 at the time, the company decided at the time it's not worth further investment, and it was decided to shut down. And in 2003, when we were reviewing that decision, Comalco was taken over by Rio at the time, and we had a meeting where it was agreed mutually that we part ways in technology development, where they didn't see us as a valuable partner, and we actually wanted to continue the business of the development. So anything happening after 2003 was fully developed by Dubal independently from Comalco. So by 2005, we had developed the DX concept, and the first pots were commissioned at that time in the Eagle section. And that was our first technology development. By 2007, we were able to work with Mubadala and agree on building Imal Phase 1 using the DX technology. In the middle, we built what we call pot line 8 to showcase the DX technology, at the same time use it as a prototype and optimization for the future sales to provide best result to the clients. So that's when we built the DX pot. Original design capacity was operate between 320 to 340 kiloamp. Today in Dubal, we're running it at 385, with expected second generation to be taken up to 400. So at that time, the technology transferred to Imal, and the DX as a pot had completed its cycle in the Eagle section. So it was replaced with what we call an upgraded version. The main idea of that was to make it a higher amperage operation, a better efficiency, and a better energy consumption while maintaining the same envelope, and to use the maximum possible of leftover material from the DX project. So that's where the DX Plus was produced, and it was commissioned in 2010, and it was chosen subsequently after the stabilization and early operation to be used for Imal Phase 2. And today, a full pot line of 444 pots is being commissioned. It's today under commissioning at Imal. So that's the basic story of Dubal. Here, I just want to focus on 2 points, and this one is the main drive today. Driving all the technology development and what we do in Dubal today is basically the energy and conservation of as much as possible of energy. The other one will be the quality and environment. These are the 2 key points which I will be focusing on as we progress in this presentation. This is just a quick picture of how when we started, what was the level of energy consumption, where are we today? You have to keep in mind we are at 14.7 because we have a lot of legacy old pots and a small number of more advanced pots. Today, the highest energy consumption pot we have is a special group of pots which are high purity to make 4.9s or 99.98 metal. And these require much more energy and special operation. And the lowest energy consumption is what we call a D18 plus, which is operating at 12.67. So that's the range of technology and range of energy consumptions we're operating today. We just take you now to the technology development and the transfer. This is just a quick review of the different technologies, where they started. So the bottom line is when we commissioned, and the top line is actually where are we today. So that's the level of productivity we have improved on every design. So today, on average, every technology in Dubal operates more than 20 to 25% above the nameplate design criteria, with improved parameter compared to the original one. And as stated, D18 plus, DX, DX plus are fully designed, optimized in the UAE using Dubal resources. We have used at many times other people to support us. We have no issues of using support of experts around the world, which add value to our business. So that's part of our business model today. Now, in regarding to the technology, today we can actually conclude by stating that the Dubal today has a proven technology, which is a proof of it is the pot lines 1 and 2 at Imal, 756 pots operating at benchmark performances with exceptional, I think, overall performance. At the same time, the DX Plus now is under commissioning, and early indications we have seen. We started commissioning them in September 15, I think. And so far, I think we have about 52 pots in cycle. And the early indications are it will be an outstanding performance pot. We've also, as a part of Alba's plan to expand, they are looking at putting a pot line 6. So we have signed an agreement with Alba to utilize the DX Plus technology, given that the pot line 6 is approved at Alba. Originally, we were looking at 400,000 tons. Now, with the latest modification in numbers which were done, we're looking closer to 500,000 tons rather than 400. So that's the Albas. This is just, I'm going to talk about the latest development of the DX and DX Plus. This is just the story of what I was calling at the time pot line 8, which is the demonstration pot line of the DX. This is where all the optimization is done and the know-how is transferred to Imal or any other client using the DX technology. As I said, technology was originally commissioned at 340 kiloamp, and within the first 2 weeks of commissioning, the team realized that it's operating well below its capacity, so subsequently the amperage was increased, and we'll show the order of the increase over time. Today it's at 385. We're actually going through the first transition where we are replacing the pots. As of end of last month, we had replaced 20 pots out of the 40 pots. So 20 pots are still in operation 6 years after the commissioning. And 4 out of the 20 which are out of operation were taken out due to autopsy requirement, due to further testing which we had to do. So basically, the life expectancy of this pot, originally, we were having expectation of around 16 to 1800 days. Today, we know we will cross 2000 days. And for second generation, we are expecting to go well beyond that one with the modification we're doing now. These are just some of the numbers for the 40 pots. Is just the two key points for me actually is the purity level, and the purity has been sustained all the way throughout the commissioning period, the full operation life, and now we're coming to end of life with an average iron level of 400 ppm and a silicon level below 300 ppm, which is a remarkable purity level to be able to sustain. As you can see, this year the level is increased on the iron. That's mainly due to the 14 pots which we have taken out this year as a result of going on iron attack. The other one is on the anode effect, and the remarkable part of it is looking at the anode effect duration. Today we are getting anode effect durations less than 10 seconds, and a huge number of them actually are coming less than 5 seconds. Maybe 2-3 years ago, to declare an anode effect, we used to wait for 8 seconds. So today, we actually declare an anode effect. If you have one reading above 8 volt, you're an anode effect. And with that one, still, we are able now to achieve very low frequencies and exceptionally low durations. This is to take you to the DX Plus. DX Plus, we have the 5 prototype original pots, which we're looking at now upgrading to the DX Ultra, which I'll explain later. Today, in the 5 pots are operating at 450 kiloamp, with our plans to take this one to 460. EMAL today commissioned at 440. Subsequently, as the gas is available further for the phase 2 expansion, which will happen in mid-November, then they can go up on the amperage and continue the ramp up. It's a decision they have to make. Today, they're commissioning at 440 kiloamp. These are the results from the 5 prototype DX Plus. And again, similar results are achieved on metal purity and on anode effects. On the efficiencies, you have to look at these pots are operating under huge constraint due to the size of them and the location they're applied in. So we have a lot of issues with crane, and a lot of workaround had to be done to be able to operate these pots. Early result we see from the EMAL pots look significantly better than this. Hopefully next year we will present that one, and we'll have a much better detail on that. This is just a general description of the DX Plus pots. And the key point in this one is we do not use any air cooling to cool the shell externally. And we also do not use any magnetic compensation, which makes the bus bar much simpler and much better for the energy consumption. This is just keeping what we were talking about early on, is on the focus on the performance and the environment. As you can see, as the pots performances were maintained and KPIs are sustained and developed further, the environmental impact of that, we've been able to sustain and continuously improve. On the HF, the total emission is less than 0.35. It's actually significantly lower than that, looking at the EMAL data. And this is taken from a cassette, and so it's a complete cycle of any emission of HF happening throughout the process. The same time, on the PFC, now we are achieving less than 10, which makes it the lowest, and this was verified 3 years ago by Jerry. Jerry is now doing one more campaign at Duval and EMAL to establish this one. Jerry Marks is a IAI guy who's doing a lot of this monitoring. And on the specific one, also the gross carbon, which is one of the lowest, is we are able to take it close to 0.5, which is a very low number. Normally, you'll be around 450, somewhere there. So which means you're sustaining the anode in the pot for the longest possible duration, which improves your anode changing. And for people who buy anode, this makes a big difference. Now we have talked about all the latest development which was done. What we had looked also, the legacy we have at Dubal, we have a lot of pods which are of the 1960s, 1980s design. And then what to do with those? And with the focus and drive to focus on environment and energy, we are relooking backward at the old pods to see what can be done. And at this point, we had two teams called in, the performance enhancement team and technology team, and we reviewed the oldest pod design is the D18. And we looked at parameter and challenged them if they can think outside the box, don't limit to what you have. Only limitation you have, you cannot touch the building, you cannot touch the fume treatment, you cannot touch basically any support function. So you have to only work within the pods and deliver a pod which can operate below 13 kilowatt energy with a improved performance and a significant reduction in the emission footprint. And actually, I thought they'll take a long time, but within a couple of months, they had come up with a design which actually today proven to surpass all our expectation early on for it. So this is just a story of the P69 Kaiser. So originally it was 135,000 tons. So I'll skip this part of it. But on the DX Plus, we have built 7 pods, taking out 7 D18 pods, replacing them with this new design, which the team came up with. And we had to do it live, so with the pot line running. And it had to be done with minimal time disturbance to operation and safely. So the job was completed 33 days without any incident and without any disturbance to the operating line. And I'll just leave you with some pictures from the actual job. So that was the old pots removed. Now the work is being done. So the new pots being installed. So this was at the end of it, after 33 days. Original target for the team was 35 days, and they completed the job in 33 days. And that was on the construction side, which I think was a remarkable achievement, running in a pot line which is operating without causing any issues. These are the results achieved over 1.5 years of operation of these pots. So keep in mind, when I'll talk later about the amperages, the design for the D18 Plus is way above this. But because it's linked to a pot line which is operating today, you have to run it under abnormal condition. But the results were remarkable. The energy consumption, our target was 12.99, and that was put by Muhammad. He says, I don't like 13, you have to change it. So we had put 12.99 as a target, and today they are achieving 12.67. At the same time, as you can see on the anode effect frequency, we had a significant reduction, more than 95% emission reduction overall. This is just some of the numbers when we were looking at. The green one is actually the design criteria for the D18 Plus, because the point of this was that you reduce energy, then you will have a possibility of raising the amperage to make more metal. So you're not allowed to build anything new, but within what you build, you have to operate and consume all the energy which you save from the project. And this challenge was given to them, and this is what you can see. So the green line is actually the expectation for 220 kiloamp. And I think the latest revision of the team, now they're revising the forecast to 230 kiloamp operation. And we expect for the energy to achieve the 12.99 original target set. Keep in mind, for the first one, we achieved 12.67, while the target was 12.99. So we expect to achieve below the target we have set for the project. Now we'll talk about the technology transfer and the different services we provide. So we have what we call a technology license agreement, and that's where we license the DX, DX Plus, or subsequently any other technologies will be developed. And that includes a significant number of documents where you need to build up the pods and be able to operate them. And then above that, we provide a wide range of technical services. We support the client in engineering, procurement, marketing, or any other part. We also do training. In case of EMAL, I was looking at some of the data for phase one. At Dubal site, we have trained about 1,000 people to make them ready for the process. So EMAL, when it was given birth, it was given as a giant and as a proper smelter. So there was no issues at all. And the beauty of the DX Plus, we don't have any compulsory requirement. We have a set of specifications. If they are adhered to, then we guarantee the performances. And if you have, we make a recommendation on different suppliers. If you have other suppliers you would like us to consider, we go visit them, evaluate them, and provide you a recommendation. Can they meet the requirement or not? And that's the strategy we're following. And also on top of the reduction, we can provide basic design for the feed studies, especially for the reduction areas. On the site services, there are certain mandatory requirement services due to the technology guarantees we provide, but also we provide optional services if required by the client, as and when required and requested. Other services Dubal provides is the technical services agreement. So if the client would like to continue the relationship and benefit from the development we do, then we have this agreement. Then we also can provide the strategic supply agreement where we can actually support the client in sourcing, procuring, and we can do it on their behalf depending on the requirement. The same thing can be done for marketing and sales. This is just some pictures actually. These are from EMAL phase one and EMAL phase one trainings. This is just to show you what is EMAL today. So EMAL phase one was the largest greenfield smelter. Today it's capable of producing 800,000 tons a year using the DX at 380. Original agreement with EMAL when we started this job was to operate at a range of 320 to 340 with a nominal capacity of 710. So today, without any fees or any attachment, EMAL is getting 100,000 ton above the agreed deal which we have signed with them due to the improvements which were done over the past few months at Dubal and then or years and transferred to EMAL. And these pots are now running. The oldest one will be 2nd December 2009. And from commissioning date today, they have not had a single failure, neither through commissioning nor the normal operation. So up to now, the original 756 are in operation without any issues. Results have exceeded the design criteria which have been given to EMAL, and it has a highly competitive costing structure. These are the results from the EMAL pot lines, and the last one is the actual performance test where after raising the amperage to 380, and the amperage raise from 350 to 380 was done in totally 12 weeks only. The performance after 1 month of stabilization from raising, a complete test was done where all the pots were copper diluted to establish the inventories and change in everything. And the performance was at 95.3. And as you can see, despite the rapid increase in amperage, the metal purity sustained or improved actually marginally at that time. The EMAL phase 2 is again another story where now it's starting or it's in the middle of completion. It's started commissioning a couple of months ago. The commissioning started at 440. The original contract with EMAL again on this pot was to be commissioned at 420. But because we were able to operate the 5 pots above that one and establish the parameters, all the data was transferred to EMAL to allow the commissioning at 440. And actually, we've transferred all the data to allow it to operate at 450, which is at discretion of EMAL. And we believe the first generation of these pots will be able to go up to 460. With the second generation, which we're working on today, we should take it to 480 benchmark. This is just some of the numbers. So EMAL, hopefully after the completion of phase 2, will be almost 1.4 million tons capacity. And if we keep in mind the creep potential of both pot lines, then they will be crossing the 1.4 million ton capacity. A PLC system of pot controller. This is the second major development, and it's an integral part of the success of the DX and the DX Plus, especially on the software controlling the pots. We believe today we have the best software available to control the pots. Our consultants we work with, they're familiar with many others, and they software to control the cells and get the best results out of it. We actually provide all level of control, so from level 1 up to level 3. So from the operator level data and control up to the senior executive level, where they can have the information presented in a format which is useful for them, while at operator level you need to provide information at a level which makes sense to them. These are some of the pictures on some snap screen. This is from about a year ago on the DX Plus at Dubal site. And each PLC unit controls 10 pots, and we have for each 2 pots, 1 display unit where you can actually look at the data. It's highly interactive with operators. All data could be entered from the shop floor, and all operation data required to support the operation can be taken from the shop floor with a lot of graphical interface where the operators don't have to go to the offices, where they can be on the shop floor. At the same time, you can actually link other equipment to this one. So today, we have the motors linked to the control units. So if you have a problem where the motors are straining due to anode being stuck or anything, actually you receive a message, so people don't continue tapping and damage the pot. And also you can link it to your fume treatment plant and other functions. So it's highly interactive. Now, this is just some of the things which we are doing as a next move. And the DX Ultra is something which is happening in the next few months. And the DZ is something we are planning to proceed in the next 3 to 5 years, most likely in 3 years' time. So what is Ultra? Ultra, what we have taken, we took the original DX when we built it with all its what was there. These numbers were benchmarked and then given to the team to provide what can they do. And the DX Ultra, these are the different steps we have taken to make sure that we can get an energy of less than 12.5. And that was the target given to the team. Today, all indications are that the performance of the Ultra will be below 12.5. A lot of what you see here as steps to be verified has been verified in other designs. So basically, they'll be incorporated. So we have a very high certainty level today of what we're doing and what will be the outcome. And coming January, hopefully, we can start putting these pots on circuit, and then we can verify the results. So the principal difference will be that these pots will operate 345 millivolt below the DX Plus best numbers. The key function also, other than the energy consumption, was we looked at the DX Plus and we identified the 2 major improvement areas requirement. And the key one was the amount of bus bar we are using for the design. So in the Ultra, you're gonna be operating in the same amperage or higher, but using less 10 tons of aluminum per pot. And the other one is on the spacing between the pots. Today, the DX Plus spacing center to center is 6.3 meter. In the Ultra, we brought it down to 6 meter. So that's the basic other two changes which were done in the design. These are just some of the work the analysis which we were doing, what can apply today, what can be applied where, and what is the DX Ultra. So this just some of the work. So these are how we are able to achieve the lower energy and better efficiency. These what things that was done. These are the expected numbers. On the DX Industrial, that's the level we expected on the first generation. In the second generation, incorporating part of the DX Ultra features, in EMAL in second generation, they will be able to achieve around 12.8 kilowatt, because a lot of the improvement, especially in the cathode design and the modification to the anode and other things, will apply also to the DX Plus at EMAL. And on the DX Ultra will be below 4 volt per pot, operating at 12.44. The other one in terms of energy is to capture a lot of heat. All you people familiar with the aluminum industry, you know that we waste a lot of heat in the process to make aluminum. And the point is come where we have to look at this one, how to capture it, how to recycle it. We are working today with a Norwegian company on this development. And hopefully once the DX Ultra installed, this will be tested on one of them. The idea of this one is to take us well below the 12 benchmark. So this is what we are thinking of today. The major energy wastages are off the side of the pot and through the gases taken off the duct. We're looking at capturing these and then being able to recycle that, capture it, whether as to use it as a heat to cooling or whether to make it into electricity or whether just to use it for desalination purpose. As you all know, in this area we have no usage of heat, so that's something we don't need. I think in other places it will be much easier because you can actually circulate the hot air to heat up buildings and other things, but this is something we don't need here. The other major work we're going to do in the next few months, some of it already started and some we are going to start soon, will be on process automation. And we believe this is a requirement to improve the technology further and allow us also to break the barrier of 12 kilowatt per kg for the reduction process. So here what we're looking basically today is, one is on the automatic anode current distribution monitoring, where you can actually, as a fact, we know today as a limiting factor of ACD is not the complete setup. There are few areas of problem which can be addressed. So with this one, you can actually have a full visibility and be able to address these issues and limitation. At the same time, we're working today with some equipment suppliers on developing a system to measure metal bath heights without human interface. At the same time, be able to take the bath temperature and report it. So these will be done fully without any human interface requirement. These are the key focuses of automation. We have a few other ideas which we, at this point, I think we need to complete this one and then further progress the process. This is the question which we want to put. A DZ is a high amperage technology which we have developed the basic concept and we have done the basic design for it. And put some of the numbers we have driven from the design. But here the question for the people here is do you want this to operate at higher productivity or energy, and what's the priority for people? You know, we have different answers, and today we're trying to provide a solution which will cater for both. But it's interesting to see what the people here think will be the drive going into the future. So this is just some numbers we have taken from different sources. I think one was on the AP newsletter, the other one was from the CRU group. So the pot we are looking actually to be beyond 600. The basic design model we have done was at 610. and up to 700 kiloamp range with a different operating range of parameter. The other one is the energy specific to be below 12 kilowatt at 610. That's the overall theme for this design. If the client would like to take it beyond the 610, the tendency will be as the amperage goes up, the energy consumption will tend to increase along with that one. So that's basically the latest development we're working on. I think in the next few months, we'll be going to our board to ask for funding to develop prototyping of this technology.